There are several catastrophic wildfires that occurred last year. Northern Ontario experienced the Kenora 51 fire. It burned over 200,000 hectares, was the largest wildfire recorded in Ontario, and saw the evacuation of several First Nations communities. Another destructive fire and the largest single wildfire in California's state history was the Dixie Fire of 2021. It lasted for 2 months, burned almost 400,000 hectares, and with entire towns being completely destroyed. This fire was a major catastrophe for the state, costing over $1 billion to control. It seriously injured and killed firefighters and destroyed over 1,300 buildings. Both of these massive fires are examples of their catastrophic nature due to climate change. Larger burned areas correlate directly to larger areas lacking vegetation. This loss of protected vegetation leaves soil unprotected from wind and water erosion. Soil, sediment, and fire ash are picked up by water runoff and eventually enter into streams and water bodies. This in turn creates harmful conditions to aquatic systems and fish, and particularly fish such as trout that need sediment-free conditions. Additional harmful effects to aquatic systems and fish habitat occur where traditional fire retardants are used on wildland fires. The safety data sheet of the most commonly used aerial fire retardant for wildland fire control in North America states it may cause long-term adverse effects in the aquatic environment and lists rainbow trout as a target fish. Other research has determined that aerial drops of this currently used retardant during salmon migration to the ocean has adverse impacts that extend beyond the acute mortality that occurs within the immediate drop and dilution areas. In other words, it has adverse impacts downstream as well as where it first entered into the water.